Good day, everyone. So our topic for today is on the synthetic division. This is actually the shortcut version of the long division and in the topic of the division of polynomials. So here I'm going to present three different scenarios that you might encounter once you do the synthetic division. So we'll have our first example. The problem is x cubed plus 6x squared minus 16x plus 9 divided by x minus 1. So this is our dividend and this is our divisor. So the first step is to equate our divisor to 0, which means x minus 1 will become x minus 1 is equal to 0. Equate it to 0. And then we will do the addition, subtraction, property of equality, which means to eliminate negative 1, we will be adding 1 to both sides. So this will become x minus 1 plus 1 is equal to 0 plus 1. So we will be canceling negative 1 plus 1. So we'll have x is equal to positive 1. So the answer here, after we equate to 0, is the value that we will be putting inside this space. That is positive 1. Now, we will be filling out these empty spaces by writing down all the numerical terms of the given dividend. So for x cubed, we have 1. For 6x squared, we have 6. For negative 16x, we have negative 16. And for plus 9, we have positive 9. Again, the numerical terms only. But before you do that, you also need to make sure that the given dividend is arranged in standard form. Because if it is not yet arranged in standard form, the first thing that you need to do is to arrange them first. But since it is already arranged in standard form, so all we need to do is just to write down all the numerical coefficient. Now let's start solving. First is to bring down the first term, whatever it is. So in this case, we have 1, so bring down 1. Next, 1 times 1. We will multiply the number that we bring down to the number that is inside this slot. 1 times 1, we have 1. And then add 6 plus 1 will give us 7. And then repeat the same process. 7 times 1 will give us positive 7. And then we have to add again. Negative 16 plus 7 will give us negative 9. Same process again. Negative 9 times 1 will give us negative 9. And then 9 minus 9 will give us 0. Now, what are we going to do with this answer? Of course, we have to write it in a polynomial form. Now, our dividend is in third degree divided by a first degree polynomial. So which means we will subtract 1. We will start with second degree. So convert this 1 into a second degree polynomial. This will become x squared. Followed by 7, which will become first degree. So this will become positive or plus 7x. After the first degree polynomial is the constant. So this will become minus 9. No need to write this one because this is already 0, which means there's no remainder. So our final answer is x squared plus 7x minus 9. Let's have another example. For our second example, we have x to the fourth plus 8x cubed plus 12x squared minus 10x minus 5 divided by x plus 3. Again, first step is always equate the divisor to 0. So x plus 3 is equal to 0. Our goal here is to eliminate positive 3. So again, addition, subtraction, property of equality. So to remove positive 3, we have to subtract 3 to both sides. So x plus 3 minus 3 is equal to 0 minus 3. So this will give us cancel x is equal to negative 3. So the value negative 3 will come inside this space because this is our divisor. Now, since they are already arranged in standard form, let us all bring down all the numerical coefficient. X to the fourth give us 1. 8x cubed, 8. 12x squared gives us 12. Negative 10x gives us negative 10. And then negative 5. Now, same process, bring down the first term. Multiply, add. Multiply, add. So 1 times negative 3 will give us negative 3. 8 minus 3 gives us positive 5. 5 times negative 3 gives us negative 15. 12 minus 15 gives us negative 3. Negative 3 times negative 3 gives us positive 9. Negative 10 plus 9 gives us negative 1. Negative 1 times negative 3 gives us positive 3. And then negative 5 plus 3 gives us negative 2. So our dividend is in fourth degree divided by a first degree. So we'll start with third degree. Third degree, second degree, first degree, constant. This is our remainder. Now, how do we write this? So again, we'll start with the third degree. So once we'll have x cubed. Second degree, positive or plus 5x squared. First degree, minus 3x. Constant, minus 1. How do we write our remainder? Now remember that this is in negative. So we will write negative 2 over the divisor. X plus 3. And this is your final answer. X cubed plus 5x squared minus 3x minus 1 minus 2 over x plus 3. Let's proceed to our last example. For our last example, we have x to the fourth plus x cubed minus 6x squared minus 5x plus 10 divided by x minus 2. Again, let's equate the given divisor to 0. X minus 2 is equal to 0. We have to eliminate this negative 2. So we will add 2 to both sides. So x minus 2 plus 2 is equal to 0 plus 2. Cancel, so we'll have x is equal to positive 2. So we'll write positive 2 here. Now, this is already in standard form, so bring down all the numerical coefficient. So fourth degree, we have 1. Third degree, we also have 1. Second degree, we have negative 6. First degree, we have negative 5. And for the constant, we have 10. Now, bring down the first term. Next, 1 times 2, we have 2. Then we will add 1 plus 2, 3. 3 times 2 will give us 6. Negative 6 plus 6 gives us 0. 0 times 2, 0. Negative 5 plus 0 gives us negative 5. Negative 5 times 2 gives us negative 10. 10 minus 10 gives us 0. Now, how do we write our answer? This is in fourth degree, divided by first degree, so our answer will start in third degree. So third degree, second degree, first degree, constant, remainder. So let's start with the third degree, 1. So this is x cubed. Second degree is 3, so plus 3x squared. First degree is 0. Since it's already 0, there's no need to write it anymore. So we'll just proceed to the next one. First degree, constant, minus 5. And since there's no remainder, this is our final answer. X cubed plus 3x squared minus 5. So, I hope you learned a lot today, and if you have any questions about synthetic division, just don't forget to write them down in the comment section below, and also don't forget to subscribe. Thank you very much, and have a wonderful day.